Hi guys. So in this video, I will be explaining you some of the top 15 important binary search based questions, okay, that are asked in most of the product based company as well as top service based companies as well. Okay, so let's understand what all type of questions that are most frequently asked. So let's get started. I hope you can see my screen now. So let's understand what are top 15 questions that are asked in interviews. Okay. So first is implementing lower bound and upper bound. So this is like the basic understanding level question. Like we have to understand like how to find out a lower bound and how to find the upper bound. For that, we need to understand what is lower bound and what is upper bound. So from here, you will get to know like lower bound of a number is the index of the first element that is greater than or equal to the target value. Okay, so what does that mean? So if we consider the array over here, like 1, 2, 4, 4, 8, 10, target is 4. So lower bound is the first occurrence of 4, which is a target value. So lower bound will be at index 2. So 2 will be the output. Okay, because it is found at a lower bound. Okay, and upper bound is the index which is coming just after the last occurrence of 4, okay, which is 4. Okay, so here if you observe, the last occurrence of 4 is at 0, 1, 2, 3, third index. So after that index will be the upper bound, which is where 8 is present, okay, which is greater than 4. The first value which is greater than 4, that will be the upper bound of that particular array, comparing with that target value. Okay, so like that we have to understand. So here we can make use of binary search. Okay, and because this array is sorted, okay, as and when we are clear that array is sorted, at that point of time we have to definitely go ahead with binary search. Okay, so this is very much crucial for interview purpose to understand like how we can get to know like when to use binary search. So if we know like there are two kind of searching techniques like linear search and binary search. Okay, so what will be the brute force technique to solve this problem? Yes, it is through linear search. Okay, if we are doing operation going through each and every element of the array doing linear search, then what will be the time complexity? It will be O of n. Okay, so it's very much simple in that way. But interviewer will not agree with this. Interviewer will ask you, can you optimize a bit more? Can you optimize it by doing it in O of logarithmic time of n? So in that scenario, whenever the interviewer asks like O of log n time complexity it needs to be resolved, then we have to go with binary search. Okay, because this is the only technique with the help of which you optimize the O of n technique to O of log n. Okay, so that is very much crucial to understand. And the array is sorted. So any operation that we are doing over sorted array, that we can do with the help of binary search technique. Okay, so this is a first problem, basic problem on binary search. Okay. Next is first and last occurrences in an array. So this is the problem statement. Like given there is a one sorted array which is given to us, we have to find the first and last occurrence of the target integer value. So here, if you can see this array 1, 2, 3, 4, 8, 10. Okay, target is 4. So we have to find out like what's the first occurrence and what's the last occurrence of this target value. So first occurrence is at index 2 and last occurrence is at index 4. So this also can be solved with the help of binary search technique. Okay. So here the array is already sorted. So what we can do, we can find the low, we can find the high. The low will be the first index, high will be the last index. I am assuming that you already know what is binary search and how binary search works. Okay. So for a context, I wanted to tell you that binary search works like a dictionary. Okay. So whenever you are trying to search for a particular word in a dictionary, then how you are searching? So let's suppose you want to search for a word, let's suppose diplomacy, diplomat. Let's suppose this is a word you want to search for. How will you search for? Will you go word by word starting from A, then B, then C, then D? No, right? You will just randomly search for a page in the middle of the dictionary and then you will see like what is the character it is starting with. Okay, so if it is starting with somewhere around like P or Q, that means you are searching for diplomat which is starting with the character D. Okay, and P or Q is coming at later stage of time. So what will you do? You will not search what is present after P in the dictionary. You will search before P and after A. Okay, somewhere in the middle, and then you will see whether you are near to your target character value D or not. Okay, if you have find out D, then it's fine. If you have not find out, we have to compare like whether that character is more than D or lesser than D. Okay, so if something around F is coming, you know like D can't be found after F, so you will see below F. Okay, or if it is C, then we have to see like that D for diplomat is coming after C. So we have to see after C. Okay. So like this, we have to keep on searching by calculating the mid value. So there will be low, which is pointing to the first index, 0th index, then high pointing to last index, then mid value pointing to the middle of those array integers. Okay. Then we have to compare the mid value with the target. If it is matching, it's fine. Then after that, if it is not matching, we have to compare that target value is greater than or equal to the target value. Okay. So we have to see like what is our target value. So after calculating the mid, we will compare with the target. If it is lesser, then what we have to do? We have to reduce the high index from the last index to mid by -1. Or if it is at more value than mid, then the low pointer, which was pointing to 0th index, that needs to get shifted to mid +1 position. So like that, we have to keep on continuously doing until and unless we find that value. Okay. And if we don't find, we have to return -1. So this is the technique for binary search. Okay. So I'm assuming that you already know what is binary search and how does it work. Okay. And these are some of the top 15 questions based upon the binary search. So the two questions that I already discussed now. Okay. So now I hope you got this question, why we are making use of binary search in this problem. Okay. Because the array is sorted and we have to find first and last occurrence. So we can very easily search. We have to search for it, right? So whenever we have to do search operation and when array is sorted, and we have to do it in less than O of n time complexity, then nothing should come in your mind except binary search. Okay. Then third problem. Then in this, what we have to do, we have to search the element in a sorted array. Okay. So there are two kind of things. One is normal sorted array and one is rotated sorted array. There are two kind of arrays. So in Walmart, these kind of questions are most commonly asked. How will you search for a particular element in a rotated sorted array? So rotated sorted array means what? So normal sorted array means if you see an array, okay, within that all the elements from left to right, it will be sorted. Okay. But in rotated sorted array, that is not the case. So if you see it with this example, it's 6, 7, 9, 15, 19, 2, 3. Okay. So if you see at first glance, you will get to know like it is not sorted, right? Because 2, 3 is coming after 19, how it will be sorted. But if you see closely, okay, the left part and right part are individually sorted. Okay, so if you observe 6, 7, 9, 15 and 19, this part is individually sorted, and 2 and 3, this right part is individually sorted. So left part and right part is individually sorted. That means it is sorted rotated array. So if the array would have been 2, 3, 6, 7, 9, 15 and 19, that means we have rotated this array 2 times to get this result. Okay, so if we rotate this array like left shift, if you do 2 times, you will get 2, 3, 6, 7, 9, 15, 19. Then it becomes automatic sorted array. So this is sorted array only, but it's rotated sorted array. It's not like a normal sorted array. So in this, we have to search for target value, which is 50. Okay, so this is also most commonly asked questions in Walmart. Okay, so we have to learn it very importantly. Okay, so here there are two varieties. First variety is if it contains only unique element. If array contains only unique elements, and then we have to search for target value 15. And second scenario is if it contains some duplicates like 15, 15, 19. If that type of scenario is coming, then how will you resolve that? So there are two kind of questions that can be asked. Okay, so here we have to make use of binary search because left part and right part are individually sorted, and then we have to modify this binary search. Okay, so we have to keep on comparing the left index with the mid index. So here we have to see that we have to first find the mid value. Okay, like first index is at 0th index, first value, so high will be at last index. We have to calculate the mid. Okay, after calculating the mid, we have to compare whether low is less than high or not. Sorry, low is less than high as well as low is less than mid or not. So here if you observe, low is 6, high is 3 and mid is 15. So low is less than mid. That means it's fine. That should be the way. Low should be less than mid value. Low value is 6, mid value is 15. You are getting right what I'm trying to say. Low is pointing to 0th index, high is pointing to last index and -1th index. So mid value will lie in between. So mid will be pointing to 15. Okay. So what should be the scenario for the binary search? Low should be less than mid and mid should be less than high. Okay, I hope you are getting the concept. Mid should come between low and high. That means low should be less than mid and mid should be less than high. This should be the scenario. Okay, But here, if you observe, 6 is less than 15. This is perfectly fine. But 15 is not less than 3. That means the array is sorted, rotated array. Okay. And left part is sorted. We got to know just from this point, like 6 is less than 15. That means left part is sorted. So now we will see the target value. Target value is 15 and mid value is also 15. It will match, it will return the value. If it would have been 9, then I am sure that 6 to 15 value is sorted. So I will see in the left part. I will not see towards the right part. Okay, why I'm not seeing towards the right part? Because I'm knowing that 6 to 15 is present in the left side, and left side is sorted because low index is less than equal to mid index. Okay, or else the reverse way is also possible. If we are searching for 2 and 6 is less than 15 and 2 is not present there, okay, so low will be pointing to mid plus 1, and then we have to again start keep on searching for that element. Okay, so like this we have to do. This is for unique element search. If it is duplicate, let's suppose it's like 7 7 7 7, then 2 3, then we have to check the lower bound and upper bound, like lower and upper index we have to see. And if both the index are having same element, we have to reduce the boundaries. We have to keep on reducing the boundary. So if it is 7 7, we have to keep on reducing again, like low plus plus and high minus minus. Then 7 7 if again came, then low plus plus, high minus minus. And then if 4 5 is coming, then we have to start searching. So like that we have to move ahead if it is containing duplicate elements. I hope you got the concept of this, right? So this is very important. You can go through the pseudocode, you will get an idea of it, like how searching an element is happening within the rotated sorted array. So this is very much important for interview. Then minimize the max distance between the gas stations. So this is famous problem in lead code. Okay, so there is a position of gas stations given, and we need to place k additional stations such that the maximum distance between any two adjacent stations is minimized. Okay, so how many additional stations that we can provide so that the maximum distance between the two adjacent stations can be minimized a lot. Okay, so position of current stations is 1 2 8 12 and 15, and we need to place two additional stations. Okay, so we have to minimize the maximum distance between the station after we are placing it. Okay, so where we can put that? So this is the question which is asked in the interviews. Okay, so this is very famous problem, so you can go ahead. We have to implement binary search over here. Why? Because the array is sorted, and whatever element we will be putting, we will be checking first whether it is lying between those two or not, and that is minimized version or not. We have to check also if that value which is coming out is the minimum version or not, and we have to maximize the minimum values. So some minimum values will be coming like 2 4 5. Okay, that we have to maximize the maximum values among those minimums we have to find out. Okay, so here also we can implement binary search. Then find out how many times an array has been rotated. This is also important questions. Okay, so let's suppose here is there 6 7 9 15 19 2 3. Okay, so we have already searched, we have already done this problem, right? Rotated sorted array to search for a particular element. So while searching for an element, what you can do in this, you can update the index value. So as soon as you keep on searching, try updating the index. So if it is not found at first position, we have to update the index. That way also you can make use of, and you can utilize the existing code. Or else what you can do normal binary search, and you can keep on searching for that element, okay, where it is present. And we have to see like till what point, the pivot point from where the array has been rotated. So if you keep on doing the binary search, you will get to know from which position the array is not sorted. Okay, so left part is sorted separately and right part is not sorted. So till what point, like 19 is the pivot point. So as soon as I'm going above 19, 2 is coming. So 2 is not coming as a part of the sorted array. Okay, so that means 2 is the pivot points. Okay, so from 2, how many elements are there? So from 2, one element is there, and including 2, it will be 2 elements. That means 2 times the array has been sorted. So if it would have been more elements like 2, 3, 4, 5, then the answer would have been 4. Okay, so any number of elements coming after 19 will be my answer. I hope you are getting the clarity on this, right? So this is a thing that we have to work upon. So yeah, you can make use of directly binary search, or else you can whatever concept you have made use of in searching in sorted rotated arrays, same thing, same logic you can utilize, but you have to update the index as well, because here we have to find out like number of rotations. So we have to keep on updating the index. Okay. So here, how to find a peak element in an array. So peak element in an array is an element that is greater than or equal to its neighbor. Okay. So in other words, if there is an element array at I, it should satisfy this condition. Like array at I minus 1 should be less than equal to array at I, and array at I should be greater than equal to array at I plus 1. Okay. So let's suppose this array is considered 1, 3, 24, 1. So peak element here is 20. Why? Because 20 is greater than the neighbors like 3 and 4. Okay, 20 is greater than 3 as well as 20 is greater than equal to 4. Number can be same. Left and right can be 20, 20. Okay, so peak element here is 20. Okay. So how we can move ahead? The normal way is to iterate through it and check for neighboring elements. Okay. So this will have time complexity of O of n, but interview will tell you to optimize it further. How can you minimize it to O of log n time complexities? For then we have to make use of binary search approach to find a peak element. So the same approach you have to do. The array is sorted except at a particular position. It can be mid or it can be low, it can be high. So it can be at some place where the element is not sorted. Okay, so here index is very much important, so we can't sort it. Okay, so what we can do, we can find a mid element and we can check it with the left as well as on the right side, and we have to keep on update the mid value. Okay, still it is left part and right part is satisfying this condition until and unless we have to keep on optimizing the low, high and mid. Okay, so like that normal binary search approach only, it will help to solve this problem. So this is also important for interview. So you will get a problem link for this. Okay, in lead code you can solve there, and if you face any problem, do let me know in the chat box. Okay, and this is also very crucial, how to find the square root of a number using binary search. Okay, so normal binary search, so what you can do, you can search for any number between 0 and that particular number. Okay, so whose square root is closest to that number. So let's suppose it's 7. Okay, so 0 to 7 you have to find out like which particular number will be closest to the square root of that number. Okay, so here what we are doing, we are calculating the mid values. If you see the example like x equal to 10, the square root is approximately 3.162. So with the help of binary search, we can find the mid value. So we have to search for that particular number till mid multiplied by mid is closest to the x value. Okay, so here 3.162. So if I consider 3, then 3 multiplied by 3 is 9. 9 is closest to 10. If I am doing 4 multiplied by 4, it is 16. It is more than 10, way more than 10. Okay, but 3 multiplied by 3 is closest to 10, which is 9. That's why the answer will be 3. So I am in need of not exact number, not exact integer value. Okay, normal 1, 2, 3, any natural number is also fine. Okay, so that is the thing with the help of which we can solve this problem. So this can be easily solved with logarithmic and time complexity with binary search approach. Okay, so it drastically reduces the time complexity. So here with less number, you will not be able to understand. If number is more, let's suppose 1,20,533. Let's suppose this is the number. Then you can understand like how many operations you have to perform if you start from 0 till that number. It is reduced by logarithmic and time complexity. So drastic change will come. Okay, so in that scenarios, this will be much more preferable, this approach. Okay, so this is one of the important interview questions. Then this is also one of the questions that can be asked in interviews. Okay, so minimum days to make M bouquet. Okay, so you are given an array of flower blooms and you need to make M bouquets. Okay, so the flower need to be picked such that the minimum number of days to make the bouquet is minimized. Okay, so you have been given with the array of flower blooms. Okay, and we have to make M bouquet. So there will be like n number of roses, let's suppose, have been given to you, and you have to create a bouquet from those n number of roses. How many bouquets you can make? So let's suppose M bouquets you can make from n number of flowers present over there. So the flowers needs to be picked such that minimum number of days to make the bouquet is minimized. So let's consider this array 1, 10, 3, 10, 2. M is 3. Okay, so we have to make 3 bouquets. Okay, so how many flowers can be picked such that the minimum number of days can be minimized? Okay, so here you need to pick flowers in a way that minimizes the maximum number of days spent, okay, to pick any bouquet. Okay, so we have to pick flowers in such a way. So how we can pick the flowers in such a way? We have to make 3 bouquet. Okay, so we have to use binary search on the number of days, like how many days are present, like 10 days, 3 days, 10 days. Based on that, we have to provide binary search operation, and then we have to check whether it's possible to create 3 bouquet or not with a given number of days. So this is also very much important. So their link lead code question is there for this. Okay, you can go ahead and solve there as well. Okay. Yeah. So this is also one of the important question, like how much is the capacity to ship packages within D days? Okay. So given an array of weights, okay, so this is a weight array. Find a minimum ship capacity such that a ship can deliver all packages in D days. So D is 5. I need to deliver all the packages within 5 days. Okay. So what should be the minimum ship capacity such that the ship can deliver all the packages in 5 days? So I want a minimum number for that ship capacity. Okay. So here we can make use of binary search for the minimum capacity. Okay. The array, if you can see, it is already sorted. And if array is sorted, we can go ahead with binary search. Okay. So this range of the search is between the minimum weight and the sum of all weights. So we have to keep on doing the sum of weight until the ship capacity crosses the particular threshold. Okay. And we have to serve in 5 days. Okay. So how we can deliver in 5 days? So here the weight is given like 1, 2, 3, it can be kg, let's suppose 1 kg, 2 kg, 3 kg, 4 kg, till that. And then we have to deliver all the packages in 5 days. So what will be the minimum ship capacity? Okay, so here we have to make use of binary search for the minimum capacity. Okay, we have to search for that specific weight. Okay, if it is 5 is considered as a minimum value, minimum ship capacity, then we can deliver all packages in D days, in 5 days. Okay. So range of the search should be in between the maximum weight and the sum of all weight. So maximum weight will be initially 0. Okay, so we have to initialize the maximum weight by 0, and then we have to keep on adding that. Okay, we have to keep on summing up the weights. After doing the binary search, we have to find the mid value, and then we have to keep on adding with the mid value, and then we have to check whether it can be delivered within that 5 days or not. Okay, so like that we have to move ahead with this binary search approach. Next is kth missing positive number. Okay, so there is given an array of positive integers. We have to find the kth missing positive numbers. So if array is 2, 3, 4, 7, 11, we have to find the 5th missing positive numbers. Okay, so the missing positive numbers are 1, 5, 6, 8, 9. Okay, so here if you observe, 1 is not present, 5 is not present, 6 is not present, 8 is not present, 9 is not present. Okay, so 5th missing number is 9. Okay, so we have to search from the first, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so after arranging the not present elements, then we have to search the 5th missing. Okay, so 2, 3, 4, 7, we will not consider that because those are already present. So which elements are not present, we have to create an array for that until and unless the index value is matching the missing number. Okay, so kth missing number. So let's suppose 5 is the number till we want to reach. Okay, so 1 is not present. First, it's for 1 is less than k, which is 5. Then 2, 3 is present, 4 is present, then 5, 2, 2 is less than 5, then 6, 6 is also not present, less than 5, 7 present, 8 not present, 8 less than 5, index value I'm considering, it's 4. Okay, then next is 9. Okay, 9 is 5th. Okay, so it's a 5th missing number. So like that we have to do that. Okay, so we have to create an array after seeing the current array. Okay, after seeing the current array, based upon the kth, what is the value of k, we have to create one new array. Okay, which contains the numbers which are not present in the existing array given to us. Okay, and based upon that we have to search for that 5th missing number. So here also we can make use of binary search to find the missing element. Okay, so first element will be 2, second will be 11. We have to calculate the mid value, and then we will be seeing like it is how many distance from the first. Okay, and then we can observe that whether it is at a mid value, and if it is at mid value, then if it is sorted, then is it coming as per the index or not. So 4 is coming, but the index value is 2 in that place. Okay, so index value is 2, but the actual value is 4. That means there are 2 elements which didn't came. Okay, so like that we can make use of to understand like where is the index value and how much it should be. Okay, so it is starting from 0. So 0, 1, 2. Okay, so that means one element is not present. Okay, so like that we have to understand. Okay, and then like that we have to keep on filling up the new array. Like one is not present, we just fill that one. Okay, and then increase the low value. Okay, and then again keep on checking what is the next element which is not present. Okay, so like that we have to make use of binary search and then move ahead, and it will be solved it in O of log n time complexity. Okay, so this is also very important for interview. Then aggressive cows based problem is also there. Okay, so this is important for lead code. Okay, and this similar to these problems also asked in interviews. Okay, you need to place cows in stall such that minimum distance between any two cows is maximized. Okay, so the stall is given at a position 1, 2, 8, 4, 9. So these are the stall locations, and cows are there like 3 cows. So if you put one cow at first stall, second cow at second stall, third cow at third stall, they will not fight with each other. But if you put 2 cows in one stall, they will fight and they will become more aggressive, right? So this is the problem. Like how will you put the cows in the stall such that a minimum distance between any two cows is maximized? So minimum distances needs to be maximized. Okay, so after resolve, you have to resolve it using binary search approach. Okay, we have to optimize the time complexity, and we have to create one table like structure like C1, C2, C3, and we have to see like till what point it is maximized minimum distance. So that will be the answer. So that you can resolve it with the help of modified binary search. Okay, and we have to keep on checking like if it is possible to place cows with a current minimum distance or not. We have to keep on comparing with the current minimum distance. So yeah, this is also a very important question for interview. Then painter's partition problem type question can also be asked. Like you are being given like n boards and k painters. Each painter can paint a certain amount of length in 1 unit of time, and you need to minimize the maximum time any painter takes. Okay, some painter takes more time. So those who are taking, like let's suppose all painter are taking more time. So we have to choose those painter who are taking the minimum of those maximum times. Okay, so boards are 10, 20, 30, 40, and painters are 2. So minimum time to paint all the boards is 60. Okay, so if you consider 40 plus 20, okay, so minimum time to paint, if you do the sum, you will see that the minimum amount of time if it's taking as 60 if the boards are split optimally. Okay, so we have to use binary search to find the minimum time, and we have to check if it is possible to paint all the boards or not within a given time. So you can solve it. Okay, if you face any doubt, you can just let me know. So here this type of question can also be asked. We have to find a median of two combined arrays. So there are two arrays. Okay, so we have to find a median of the two arrays. Okay, so like 1, 3, 2, 4, 5. We can merge them 1, 2, 3, 4, 5. So median value will be 3. Okay, so with the help of binary search, you can solve it with O of log and time complexity. Okay, so this is like partitioning, array partitioning. Okay, so we have to combine the two arrays and then we have to do binary search to find the mid value. Okay, then we are given with a 2D matrix. Okay, where each row is sorted. We have to determine if a target number exists or not. Okay, so target value is 5. Okay, and we have to see whether 5 is present or not. So we have to start from the top right and we have to reach to bottom left, and we have to keep on comparing with the target. Okay, so top right is what, 11. Okay, so 11, then we have to go towards left 7, then 8, then 5, then we have to keep on checking it is at a how much distance from the target, and based upon that we have to move our pointer. So we can do this best with the help of binary search approach. So it is just an enhancement of that. Like if there is a binary matrix, our task is to find the rows that contains the maximum number of ones. So if there are multiple rows with the same number of ones, return the row with the smallest index. Okay, so the row which is containing the smallest index values, we have to return that. Okay, so if we consider over here in this matrix, so 1, 1, the second row is containing most number of ones. So second will be the output. So here also with the help of binary search, we can go row by row and we can search like how many ones are present. Okay, so like that we can find the exact result. Okay, so it's like a 2D matrix, so we can do similar to what we have done in the previous question. Okay, so like that, these are some of the important questions that are present in binary search type of problems that can be asked in interviews. Okay, so you can go ahead and solve these problems through lead code or geek for geeks. Okay, and then you will see like you are prepared for the interview. If you cover up only these 15 questions, no, you will be good to go. Okay. And if you want to give me a detailed solution on a particular set of problems, you can comment it down below. I will make separate video on those kind of problems, as this video was specific on what all type of questions that can be asked. So I have prepared based upon that only. I have not gone into details of each of these problems. So if you want me to create those, you can just ping me down in the chat box. Okay, so see you in the next video. Till then, it's Dave Jitwa signing off. Bye bye.